Okay, in this video we are going to do some practice problems, get ready for the test we have coming up in pre-calculus. So let's see what we got here. Number one, for the following angles, first A, sketch the angle in standard position. Here in one, our angle is given in degrees. So here is our Cartesian plane. Remember, we're going to start here on this initial side. That'll be 0 degrees. And as we go around, we'll count by 90s. Oops. The first quadrant here is 0 to 90. Second quadrant will be 90 to 180. Third quadrant, 180 to 270. So if I'm going to sketch this, I want to do 310 degrees. I will start my arrow on the initial side, and I'm going to start opening up. So here's 90, and then 180, 270. If I hit here, I've gone a full circle, and that's 360. And I've gone too far. I want to back up to 310. So 310 is going to be right here, somewhere in the fourth quadrant. So that's part B, determine the quadrant in which the angle lies. Again, that's fourth, so we'll put a 4 there. And for the last part, we want to determine one positive and one negative coterminal angle. So to find those coterminals, we are just going to take this given angle and add and subtract full circles. So if we're here at 310, and we want to find a negative coterminal, we will subtract a full circle 360. 310 minus 360 is negative 50. So there's our negative coterminal. To find the positive, we'll just change that minus into a plus. And 310 plus 360 is 6. Oops, that's a terrible 6. My pen's getting glitchy. 670 degrees. All right, for question 2, it's the same instructions, but now our angle has been changed into radians. So our angle is negative 4/3 pi radians. Let me move this up here. First, we want to figure out what quadrant our angle lies in. Remember, as we go around the circle here, every quadrant is 1/2 pi radians, or half the circle is pi radians. So again, as we're working our way around, if we go one quadrant, that'll be half pi. Another quadrant will take us another half pi, or to 1 pi. If we continue around, we'll have 3 halves. Why is my writing a 3 so hard? 3 halves pi. And if we go all the way around, we're back to 0, or 2 pi radians. Now be careful here because we are going in the negative direction. So negative 4/3 pi is the same as negative 1⅓ pi. So we're going to start here on our initial side, and this angle will open clockwise. So this would be negative 1/2 pi, negative 1 pi. If we go here to negative 1½ we've gone too far. So here's our negative 1 pi, and then another third is going to put us here into this quadrant. And for the answer to part B, that is quadrant 2. Now to figure out the positive and negative coterminal, I'm going to start with the negative 4/3 pi, and I'm going to add 2 pi. Or to get the common denominator, 2 pi is the same thing as 6 pi over 3. So now if I add a negative 4 plus a positive 6 pi, I'll get 2 pi over the common denominator 3, and there is my positive coterminal angle. To find the negative coterminal, we would just turn this into a minus. We would subtract the two angles. Negative 4 minus 6 more. It's like adding the opposite. So that would be negative 10 pi over 3. Negative 10/3 pi. Okay. See here, number 3, we are going to convert in this direction angles to degrees. So they give us here our angle in degrees, that's 450. We're going to multiply by the magic fraction, and in this case that will be pi on top, 180 in the denominator. Because they gave us degrees, we want degrees in the denominator, so they will cancel on the diagonal. And we can also drop the zeros. So we're left with numerator 45 pi, denominator 18. And let's see, that can reduce down here. We can divide by 9. If we divide each numerator and denominator by 9, where did my pen go? There it is. We will get 5 pi over 2. So again, that reduced down. 5 halves pi. We've turned our degrees into radians. In number 4, we're going in the opposite direction. So here our angle was given in radians. We're going to multiply by the magic fraction. But now the 180 is on top, and the pi is in the denominator. So again, on the diagonal, here the pi's will cancel. And we can just multiply straight across 7 times 180 and then divide that answer by 5, and we get 252 degrees. Number 5, complement and supplement. Remember, the complement is 90 degrees minus the given angle. So for part A, the complement, that's supposed to be an m, is 90 minus 24, and 90 minus 24 is 66. Oops. So 90 minus 24 is 66. For also part A, the supplement of the same angle is 180 minus the given angle 24, and 180 minus 24 is 156. I looked up here. Didn't I say that was 66? 66. 90 minus 24 is 66, and the supplement 180 minus 24 is 156. And oops, I almost forgot that those are in degrees. Now, on to part B, complement and supplement. Here our given angle is different. It's bigger. So again, complement is 90 minus given. Supplement is 180 minus given. In the complement, when we subtract, 90 minus 126 gives us a negative answer. And it doesn't matter what the number is. As long as we get a negative, there is no complement. By definition, complementary angles must be positive angles that add up to 90. So here there is no complement because our answer would be negative. But when we do the supplement, 180 minus 126, that turns into a 54. Supplement is 54. Number 6, complement and supplements in radians. So the complement is going to be half pi minus the given angle, pi over 12. And the supplement will be 1 pi minus the given angle, pi over 12. Let's see this complement up here. Let's get a common denominator. It would be 12. So we multiply top and bottom by 6. 6 times pi is 6 pi. 6 times 2 is 12. Now when we subtract, 6 pi minus 1 pi is 5 pi over 12, 5 twelfths pi. And down here, our pi would be 12 twelfths pi minus 1 twelfth is 11 twelfths pi. Okay, I believe this is all the 4-1 section material. Okay, this is also 4-1. Find length of arc, area of sector. We've got a circle. Our radius is 15 inches. That's a 5. Central angle is 120 degrees. Now remember, when we're dealing with these new formula, nothing will work with degrees in there. So real quick, we have to convert those 120 degrees into radians. So that'll be the magic fraction here, pi on top of 180. So we can drop the zeros, reduce the 12/18 down to 2/3. Our angle is 2/3 pi. So the 120 degrees is out. We'll use 2/3 pi for all angle measures. And first let's do the arc length. Arc length formula is S equals the radius times angle theta. Our radius, as we've already said, is 15 inches. Our angle in rads is 2/3 pi. So if we multiply straight across, we're going to get 30 pi over 3, and 30 divided by 3 is 10. So 10 pi. For the length of the arc, I'd rather see that, as a number maybe with a decimal in it. 10 times pi is 10 times 3.14, or 31 point, where's my decimal? 0.4 inches. Don't forget the units here because this is an applied problem. So if we look back to my terrible sketch, what we found is the length of this piece of the circumference. Just a piece of that circumference is called a length of arc. And now we're going to find the area of this same piece right here, this sector, swept out by that 120-degree angle. Now we have a new formula for this. Area of a sector is 1/2 radius squared times angle theta. So here is 1/2. And then we're going to have our radius is 15, so that'll be 15 squared, or 225. And we will multiply that by the area of the sector, 2/3 pi radians. Okay, now at this point I would take out my calculator and do 225 times 2 times pi, get that value, and then divide by 6. My calculator told me that the area is approximately 235.6. Let's see, our units here are inches, so that will be inches squared because we're dealing with area, and there's supposed to be, there's my decimal. Okay, so that's number 7, 2 problems in one, arc length and area of a sector. Number 8, now we're getting into the 4-3 section, the right triangle trig. So here we got a couple sides of a triangle. We want to find all 6 trig functions. Step 1, find the missing hypotenuse. A squared, come on, a squared plus b squared equals c squared. So if you square this, you get 25. 25 plus 16 is 41. Hypotenuse is root 41. And I encourage you to leave it as a radical. Don't turn that into a decimal. So let's start figuring out some trig functions. Sine from angle theta is opposite over hypotenuse. So that will be 4 over root 41. Now we are going to rationalize this, but before we rationalize, real quick, let's find its reciprocal cosecant. So cosecant, we just flip it upside down. That's root 41 over 4. Now when we come back here and rationalize, multiply the numerator by root 41, so that's 4 roots of 41. And our denominator will be the root of 41 times itself, which is just 41. So 4 root 41 over 41. For cosine, cosine is adjacent over hypotenuse, so that'll be 5 over root 41. And just like we did for cosecant, let's find the reciprocal of cos. If we flip over cos, we get secant. So our secant value is root 41 over 5. And then we'll come back here. I'll rationalize here to the left. When we rationalize this, multiply the top by root 41. And the denominator will now be 41 radical free. Finally, for tangent here, tangent is opposite over adjacent, so our tangent value is 4/5, and that means the reciprocal cotangent value is 5/4. Here for these, we're just going to do them on the calculator. Again, I made it in all caps. Be sure your calculator's in the correct mode. So here for this one, that is tangent of 41 degrees. Make sure you're in degree mode. Punch it in, 41 tan. And the directions do say to 4 places. So the first one here is going to be 0.8693. Now, cosecant is not a button on the calculator, but its flip is, and the reciprocal is sine. So what you're going to punch into your calculator is get 7. You're going to take the sine of that 7 and get the answer, but you want to flip that over with the 1 over x key, or remember the blue TIs might have it as x to the minus 1 power. So we're going to do 7, take the sine and flip it over. You should get 0.1989. Oops, excuse me, that's the wrong one. That's the answer to number 11. Up here, that should be 8.19. come on. Come on. 2055. That's better. Okay, now we're done with the degree stuff, so turn your calculator to rad mode, and I would do it like this. Do pi divided by 16 equals. Once you've hit equals and you have that as a decimal, then you hit the tan key. Now this answer is 0.1989. Down here, what we're looking for is the cotan of the same angle. So we are going to do pi divided by 16 equals. Cotan is not a button on our calculator, but its reciprocal tan is. So then we're going to hit the tan key. Now that's the answer we got right up here. But now that we're going to flip it over to get cotan, you would finish off with the 1 over x, or x to the -1 key to find the reciprocal. And then that turns into 5.0273. All right, these next couple, these come right off the table. The table will also be provided on the test. So first, let's do 14 first. It's the easier of the two. Tan of 30. Well, here's our tan row. Here's our 30-degree column. They intersect right here at the square root of 3 over 3. Above 13, cosecant 60. Well, cosecant is not on the table, but its reciprocal sine is. So we're going to find the sine of 60, and whatever the sine at 60 is, we're going to flip it over. So here's sine, here's 60. That is the root of 3 over 2, but we want to flip that to get cosecant. So that will be 2 over the root of 3. Now we do want to rationalize that denominator, so multiply the top by a root 3. And when we do the same down here, root 3 times root 3 is just 3. 2 roots of 3 over 3. And what do we got here? The last couple here are just going to be solve the triangle. So in this one we have two sides, no angle. So we will first use the Pythagorean theorem, find the missing hypotenuse. 15 squared plus 25 squared, we get that value, and then square root, and that turns into approximately 20.5. Okay, 20.5. Now we have all three sides. We can find any we can go here to angle A and use any trig function we want. I like to stick to the stuff they gave us. So here for A, I would use opposite and adjacent, so I would use tangent. Tan of angle A is opposite over adjacent. But you could do sine would be 14 over 20.5. Cosine of A would be 15 over 20.5. There are multiple ways to set it up. If you do everything correctly, remember we're going to use the inverse key. We're going to do 14 divided by 15 equals tan inverse key, and we get angle A is approximately 43 degrees. Once we know this angle here is 43, subtract it from 90, and angle B turns out to be 47. Although you could get angle B also with any of the 6 trig functions. So we did solve the triangle. We found the missing hypotenuse. All angles have now been found, and we can move on to problem 16. Now here, we do want to find all missing info. The first thing and the easiest thing to find is the missing angle B. Angle B will be angle A subtracted from 90. So up here, angle B is 53. Now, I'm going to label across from angle A, I'm going to call this side A. And across from angle C, that will be my hypotenuse C. So let's see, if we're down here at the 37-degree angle, we do touch the 12 side. So that would be the adjacent side. And we're looking for the hypotenuse here. So I could use a sine of 37. Ooh, no, my bad. Cos. The cos of angle 37 degrees is going to equal the adjacent side, 12, over the hypotenuse C. And here I could give those the old switcheroo. So side C is 12 divided by cos 37. Now if you punch everything in the calculator right, side C there should be about 15. 15. So now that we got 15 for the hypotenuse and the other side 12, we could do a little Pythagorean theorem to find the missing side A. Or you could also do a trig function. Here it's not that hard. The tan of 37, the tan of the 37-degree angle is opposite A over adjacent 12. So here, tan of 37, multiply that by 12. And for the shorter side here, we should get A is about 9, roughly 9. All right, and there is one more question after the solving. Here, given that cos is 1/4, they're asking you to use the Pythagorean identity to solve for sine. So we are going to have sine squared plus cos squared. Well, cos is out. We're going to put 1/4 in its place, and we're going to square that 1/4. 1/4 times 1/4 is 1/16. And that's going to equal 1, but let's rewrite 1 as 16/16. So to start to get sine alone, we're going to subtract this from both sides. 16/16 minus 1/16 is, whoop, get out of there. Whoa, not that. 15/16. And now to get sine by itself, we would square root. Let's square root the numerator. We'll just leave that as a root 15. The square root of the denominator is just 4. So our sine value is root 15 over 4. And that ends the practice test. Study up for the test. It's coming tomorrow. And don't forget, you can also be studying for the upcoming midterm.